Here we're going to look at question 35 from the NSAA 2018 paper. So in this question we're given the following circuit representing a variable resistor which goes between 0 and 10 ohms and a lamp which has a resistance RL. We're told that the voltage or the battery of in this circuit has a constant voltage, and we're also given a graph of the voltage against the current through our lamp. Finally, we're told that when the resistance through our variable resistor, is 4 ohms, and the current through our lamp, which is just represented by I, is 2 amps. So what the question asks us is, what is the power dissipated by the lamp, which we call PL, when the resistance through our variable resistor is 0 ohms? So if you'd like to have a go at this question yourself, then just please pause the video now, otherwise let's have a go at it. Okay, so to begin thinking about this question, let's first look at the information which we've actually been given, and let's see if there's anything we can get off of it particularly easily, just because it might help us think about how we can actually attack the question. So straight up, we're told that when the resistance through our variable resistor is 4 ohms, the current through our lamp, or the current generally in our circuit, I, is just 2 amps. So if we use our diagram, then we can look for the current at 2 amps, and we see this is going to correspond to a voltage of 6 volts. Passing through our lamp. So we know that VL is going to be 6 volts when the current is 2 amps. So while this isn't necessarily useful straight away, it's just a handy thing to sort of keep in mind. Although I'm not sure there's any other information we could get very easily off of our diagram and our circuit. So let's go ahead and actually think about how we can find the power. Well, what actually is power? Especially in a circuit, there's one useful equation which comes in handy quite often. And that is just that P equals VI. The power through a component is equal to the voltage across it multiplied by the current through it. So if we're trying to work out the power through our lamp, then we need the voltage across our lamp and the current through it when our variable resistance is set to 0, which is what we're looking for. So let's think about how we could find each of those. Well, when the resistance through our variable resistor is just equal to 0, then this component just has 0 resistance and is essentially just a wire, in which case the voltage across our lamp is just going to be the same as the voltage across our battery. So it's going to be the voltage of our power source. Once we've then got this voltage of our power source, all we have to do to find the current is use our graph here. We can just find the voltage on here, draw across, and find out what the current through the lamp is going to be. And then we can just multiply these two values together to get the power. So now we've got a bit of a plan, let's go ahead and actually try and find these two things. So let's begin by looking at the voltage. Now, as we just said, when the resistance to the variable resistor is 0, VL, the voltage across the lamp, is just going to be the voltage of our power source. But let's look at the situation we already know. So we're told that when the resistance through the variable resistor is 4 ohms, then the voltage across the lamp is going to be 6 volts. But there's also going to be some voltage across the variable resistor, which we don't know, we're not told at all. And then the voltage across the power source, or of the power source, is just going to be equal to this 6 volts through our lamp, plus whatever the voltage across the variable resistor is. So if we find out what the voltage across the variable resistor is in this case, we can find the voltage of our power source, which, since it's just constant, is going to be exactly the same as VL in the case where R equals 0. So let's think about how we could find this voltage across our variable resistor. Well, there is a rule which is pretty much always helpful when it comes to circuits and trying to think of voltages, currents and resistances, and that is Ohm's law. So if we want to find the voltage across the resistor R, or the variable resistor, then we can find this voltage by multiplying the current through the circuit by the resistance across the variable resistor at that point. So we were actually told the current in the question, it's 2 amps, and we're told that the resistance of the variable resistor is 4 ohms. So substituting these in, we just get that VR is equal to 2 amps multiplied by 4 ohms, or 8 volts. So if there's 8 volts travelling across our variable resistor and 6 volts across our lamp, then we know that in total the voltage of the power source is just going to be equal to 6 volts plus 8 volts, or 14 volts. So What this means, from what we worked out up here, is just that the voltage across the lamp in the case of the variable resistor having zero resistance is going to be just 14 volts. So now that we've got this voltage, we can go ahead and find the current. So from the graph, we can see that we can just draw along here at 14 volts, and moving down we see that the current is just going to be 3 amps. So now that we've got our voltage and our current, we can use our equation for power, that P equals VI, and multiply the voltage across our lamp by the current through it, so 14 volts multiplied by our 3 amps, giving us a final power of 42 watts. So our final answer is just going to be answer E, given in the question.